So permissions for local firsts. So I think it was 2019, you said, was the local first manifesto, but is as a pattern, it's been knocking around for a long time, and it's been something that's kind of a quiet side obsession of mine probably since the mid-2000s as a pattern, as a way of working. So working with electric, it's been an enormous kind of pleasure to think about how to do this well, how to write a slightly new version of how you might do permissions for AP databases, and to try and think through clearly some of the challenges and come up with something that's kind of both performant and usable. I'm going to go through briefly just a few bits and pieces, like a bit of what do I mean by local first sync. I think it can mean different things to different people. I'm going to look at some of the other databases that have worked in this area and done similar things. It's not like a new technology. I'm going to look at some of the generic challenges. There are things that anyone doing local first sync has inevitably to deal with. I'll run very quickly through the actual DDLX we've made, which is there's a kind of a language and some metadata. It's not very extensive, and I'm not going to do all of its kind of internals, but I'll just kind of explain briefly how that works. And then there's some bits of choices where we could have gone one way or another in our designs, and I'm just going to talk through some of those kind of quite particular design choices we've made. Local first sync is really a special case of just replicating data. We're copying data from one database to another. So data replication in its kind of most generic form is simply you copy this database to that database. But that's not kind of good enough for our needs. So you want to limit, you want to do partial replication. You want to say just this subset of data goes to the other database. So you need mechanisms for defining what subset of data do you want to send to the other database. And then on the other database, if it doesn't trust you, it wants to be able to introspect your data and say, what are you sending me? Is it the right shape of data? And who are you? Do I want to accept those changes from you? So once you kind of add partial replication and the idea of a differential user, you have to have mechanisms for controlling that flow of data. And then we're going in both directions. So we're passing data from devices to a central database and from a central database to devices. So in a way, all those questions have to happen at both ends of all those replications. But it's not a symmetrical relationship. Actually, we have a central database that we trust and a mobile device that we don't trust. The central database has all the data. The mobile has a subset, and its sharing with other devices is mediated by the central database. So actually, what we're interested in are just those questions at the server side mostly. You might have some of them on the mobile device, but mostly it's at the server side that you want to ask the questions for what do I send and what am I prepared to accept? And this is kind of what our permission system does. And the extra thing that isn't just like replicating is that it's actually under the control of the person on the device side, so that there's an extra step of choosing what am I going to sync comes from the user into the central database, and then that gets used to send the data back. So it ends up looking, what starts off as replication ends up looking a bit like a kind of query response, but actually really what it's doing under the hood is simply data replication with some filtering and some permissions on top of it. This was a brief history, but a brief history also of my work in this area. So I worked at BBC R&D. This was in 2008. I was working on collaborative video editing systems, and kind of met some of these problems. How do I partially replicate my data? How do I secure that data? And actually I was looking through some old code, and I found a Python library I wrote in 2008, which actually is a sync layer between a cloud database and backbone in this case as a local data store. So this was in some ways me doing very similar things that I'm doing now 15 odd years ago. Since then, the kind of field has matured. These are some of the databases I've worked with that support local first kind of patterns. And this is some of the variety of permission systems that they use internally to do those permissions, those filtering, choosing which documents to replicate. And in DDLX, we've borrowed some of the patterns from some of these other things, some of it very much from the original, the kind of OG, which is CouchDB, some stuff from Couchbase. I've got quite a lot with Firestore. I'm quite a fan of Firestore and the way it works. And some stuff from the way kind of Postgres or Superbase works. So we're working with Postgres. So a lot of the syntax or the kind of style of defining stuff, we've kind of worked with a Postgres style of defining things. So it's like we want to make something that builds on some of that history and some of those good patterns for defining local first sync, but make it feel kind of natural and an extension of the way you work with Postgres. And permissions for local first sync have particular problems. It's not just like another permission system. It is another permission system, but it's one that has to deal with some of the kind of inevitable problems you have if you have databases that are disconnected from each other sometimes. The first and maybe the biggest one is that you don't have your application layer you might have in a conventional web app simply isn't there anymore. And so we have a thinner sync layer in the same place where you would have middleware, application logic, doing validation, doing permissions. So that is now replaced with a slighter layer of code, which is mostly kind of declarative, but it has to be as performant in terms of being expressive to capture business logic. There's no point in removing your application logic if you can't still support the needs of the business in terms of securing data, having a granularity about defining who can do what. So we need something that kind of remains as expressive while being a kind of slighter layer. And it also has to be performant enough, it has to be fast. We want to be able to run this logic for every operation passing through the database. If we use RLS from Postgres, we have to, at every request, go back and ask the database for more data. And the performance hit of running backs and forwards, every read and write is a complete killer. So we want something that has some degree of expressivity that allows us to run very lightweight and very fast in the sync layer, so that the data can kind of flow easily. The other problem is sometimes you're disconnected. So if you're connected to a central database, you can use that as the reference for like, what are my permissions? What am I allowed to do? But ideally, it would be nice to be able to know that stuff locally so that you don't need to refer to the central database to check your permissions. You still want to enforce the permissions when someone writes some data, but before you enforce them, you want to know what they are. You don't want to write some data on your device and then fall over and trip up when you connect later and suddenly find, oh no, there's a permission there that's stopping me do that. That's a very bad user experience. So we want to make the permissions that we define centrally portable so that they can be evaluated on the device locally. And the last kind of inevitable challenge is consistency. We've got a database that provides very strong consistency guarantees for concurrent writes. And we need a way of defining the permissions that control that data to be concurrent with the data it controls. We can't have be writing rules into an external store of kind of permissions, which we then refer to separately, because that wouldn't any longer be concurrent with the data it's controlling. So we need something where the rules are implicit in the data that they control. And whoops, next one. So I'm just going to run briefly through what we've actually made. It's called DDLX. It's like an extension of a DDL. And it's got four kind of core principles, core bits that it uses. It's got roles and grants, which are extremely similar to Postgres' own ones. They're separate, so there's things in there called roles and called grants, but they're Electric's versions of those. Assignments are sets of rules that define who gets which roles, and scopes are a way of doing a lightweight discrimination between rows in a table. So instead of having a fully flexible procedural code-based filtering mechanism, we have a way of partitioning the data up based on scopes. Internally in Postgres, there's some metadata, assignments, grants, roles, and internally they have some scoping. The language we use is SQL-like. It's made to look very like using normal PostgreSQL. There's basically just two statements: assign, which gives people roles, and grant, very like Postgres' own grant, which says what that role can do. So here, Electric assign project member to project member's user ID simply says, give all the people mentioned in project members the role project member for that particular project. So that's a scoped permission role based on the content of one of the actual tables that's holding data. And the grant below says, then gives that person grant all on projects to projects member. So with an assignment, you give roles to your users, and with a grant, you then grant that role permissions to access the data. Reading that, so it's like SQL-like, but it isn't actually SQL. So to use it, you use our Electric proxy, which understands both the normal SQL you'll use, but it also speaks DDLX, and it will intercept those requests. And it actually talks Postgres to some custom functions that we've installed in the user's Postgres. So as I said, grants and roles are almost identical functionally to Postgres' kind of existing ones. So grant all on records to admin is normal Postgres grant, and Electric grant all on records to admin is a DDLX version that's functionally identical. Where it differs is that in Postgres, you actually use grant, use the same statements to attach a particular role to a user. And that user is a database user, and so it lives in PG catalog, PG user, and this will be the result. If I did grant admin to Paul, it would give me the admin right, it would make me a member of that. And roles and users are in effect all kind of users in Postgres land. But where DDLX differs is it uses assignment to read. So this reads from a table of admins. It reads the user ID, admin's user ID, writes that into a metadata table that says Paul is now an admin. So the users aren't database users. They're reading from a table of users that's defined as part of the kind of application data. And the second way it's different from normal Postgres is scopes. So scopes are simply, they're basically a foreign key. So you're saying, say for this project, we're going to say for the project itself and all its related data, that's a subset of all your data, and therefore it can discriminate between data in tables based on its relation to that project. So you can have grants like this. So this isn't scoped. This is very similar, if not identical, to a normal Postgres one. And this is the same, but now scoped to a particular project. So the role is no longer admin, it's projects.admin. You're the admin of a particular project. And it's reading that from the table called project admins. And then, so the role ends up with a scope, and the grant, you then give it permissions to do things, says this is for project admins. So every admin of every project gets access to the project itself and its related rows that can be in other tables. So in this case, it's actually the comments table. And a table, projects have issues and issues have comments. So we can traverse like the graph of relationships of primary keys to define a graph of the scope itself is a graph through the data. And this is not as powerful as using something like RLS or the way something like Firestore would allow you to run arbitrary requests against the database. But it gives you enough granularity to do 80–90% of the kind of business logic you want to discriminate between rows. So it's kind of good enough row level filtering. And you can actually do column level filtering as well. So on reads, if you want, you can do partial rows. So instead of actually replicating full rows to people, you can pass different views depending on the roles someone might have. Some people can see more and some people can see less of your full data. And this helps in terms of performance because in the sync layer, we don't have to refer back to the whole database. We have a relatively compact set of metadata that we can pass to the sync layer kind of with the same snapshot as the data that's being read, so that we can run the logic to determine if this is allowed both relatively quickly and in a way that's consistent with the data. If we had to go back to the database and ask for some other information to do it, that data wouldn't be consistent with the update that we're judging. So this allows us to both be kind of performant and consistent in the way that we kind of make judgments about access. And that same compactness of data allows us to pass the same metadata into local devices. So you can actually, before you send the writes to the database to have it fail, you could know it would fail locally, so that you don't have that kind of difficulty when you're working offline. That's the kind of the structure of how the thing works. So it's like roles and grants with users taken from the user's data and lightweight metadata to be used at the point where you're making the judgments. And I just want to go through, there's a couple of things that we ummed and ahed about and were undecided about in how it should actually behave. I'm going to go through one in like the read path and one in the write path. We made particular kind of opinionated choices about what happens. Firstly, in the read path, we have a way of asking for data that we call shapes, which is a directed graph for your data, but we have a scope as well. And these are two separate directed graphs. This one is like a select, saying, I would like this subset of all my data, please. And this is another one, which says you're allowed to have this subset of all your data, please. But they're not the same ones. And we initially had them as being the same one. We thought, let's have a common DAG, which would define, say, a project. And you could say, you can have this project. And that's kind of, in some ways, optimal, because you can save the work. You can simply validate the request and go, if this person is asking for all the project data, and you can have all the project data, you can have a kind of an efficiency of not having to recheck every request. And for a while, we were working on this basis, and this is what, say, Firestore does. On Firestore, every request is validated, and it doesn't have to revalidate it. So it's a kind of an efficiency optimization. But we decided very distinctly to separate those out because it allows the requests, the flexibility for developers to have different shapes from the slightly more static access rules that are being enforced by the database. You might have a shape which crossed across several scopes, or you might have a shape which dynamically changes while the subscription is happening. So it allows greater flexibility for the developer and greater freedom in terms of the kinds of requests you can make to have those two separate. So we've chosen to separate those two. And finally, the other kind of thing we've been looking at is what happens when you write. What happens when you're offline and you make a write against a particular set of permissions. Now, here we've got a device and database with a common set of permissions, and they're in sync, and they agree about what's possible. And I go offline and I make a write against permission set number 1. But when I go back online, the permissions and the central server have changed. Number 2 now disallows this write. And there's a choice about what the correct thing to do is here. There isn't like a clear correct answer. It's like a feature of the nature of this permission that was given. Was this permission irrevocable? Did we promise you that we would always honor that permission we gave you? Or do we reserve it? Do we reserve the right for someone who's changed it here to be able, while you were offline, to change their mind? And we've been thinking of these as hard and soft permissions. Soft is something that's where you respect the permission that you gave to someone. And it's soft because it allows cheating. It's formally correct. We can merge different devices with different sets of permissions and merge correctly the permissions and the data. But it allows cheating because the database, even though it's formally correct, isn't a closed system. People can step outside the database. They could, you could have 2 devices. You could be logged in on one and logged out on the other one. You could check what one of your colleagues had done or what a competitor had done on the logged in database and use that information to, while you were offline, enter some information on the other database. Or say you were sacked from your job and they simply didn't want you to use the app anymore, but you're offline. And so you carry on, you're sacked on Monday and on Tuesday you damaged the corporate data. So it's formally correct, but allows some potentially unwanted behaviors. So the alternative is a hard permission, where you, in fact, it's more like rebasing on top of, so when it reconnects, the changes in the permissions are rebased on top of the state of the database, whereas a soft one is more like a merge. And this allows someone else who's kind of like got greater authority than you to change the permissions that are available to you. And when you connect, this one will win. And these are both kind of automated merge strategies. And you could, of course, you could open them up to humans. You could say, we've got a conflict, someone has to choose. And the strategies for how we do that kind of resolution are something we're thinking about and working. That's it. If you want to check the syntax out, it's here. It's on the website. It's not working yet. We're in the middle of implementing it, and it will probably be pretty close to what's there. There might be slight changes. Yeah, that's it.
Great.
Okay.
Brilliant.
Do you want questions now, or questions, or you can just come and find me and ask me questions. Questions? Yeah. Yeah. Do you want?
Yeah. Does this depend on native?
Does this work, Chris?
Just shout. We can all.
Yeah.
I think we can hear you.
Does this depend on native Postgres extensions, or can I run this on a hosted Postgres like Neon or Superbase?
So it's got a kind of, technically it's got a couple of pieces. We install some functions on the Postgres, which isn't an extension. It's simply some custom functions. And then we have a proxy in front, which is really just for kind of it does other things, but in this case, it's just for prettiness. It's just so we can have something sexily SQL-like and kind of easy to write, rather than the ugly custom function, writing select, whatever. But if you want, you could use the function. The functions are there, which are identical to the kind of DDLX SQL. And then it has those metadata tables internally, which are then used by our sync service. So it creates some, the state is all persisted in the normal Postgres, and it should work. We haven't got it working in Superbase yet, have we? Quite? But it should. It should work. It should work with anything that is like Postgres-like.
Nice, very exciting. Thank you.
Thank you.
Information system is good. Yeah.
Okay. Yeah, but it seems based on the RBAC, can we do the ABAC? Like, for example, a post could only be deleted by the owner if it's not published. Yeah, can we do that?
So you're saying if you haven't yet published something,
Yeah.
the person who created it could be the only person who could delete it.
Yeah, if it's the owner and the post is not published.
Okay, so there's one bit I haven't touched on here. So when the function evaluates whether or not an operation is allowed, one of the things that it can see is the current user's ID. And you can have a check function on the operation which says, for instance, this field, say you have something called owner ID, on create must be the current user ID. So you can enforce that a particular ID of a user on a particular row in a table is the owner. So you can kind of know who the owner is, and you can give that owner particular permissions. So you could say, grant to owner ID on address record, update or create, and then the fields you wanted to give them access to. So you can both know who has created a record, and you can grant them specific permissions. So you can kind of limit, you can in fact create ownership of a record.
What if the property is not the user ID? It's like the publish.
You can say which fields you want to use. There's the way that you grant things from your data. There's several choices. You can actually run kind of if statements and go, if a particular field has this value, then grant the permission. So in terms of, it doesn't cover maybe every way you might model naturally your permissions in your data, but there's, if you go and look in the syntax, there's quite a lot of choices about how the actual permission is in the user data. And we kind of aggregate that into a table which called roles, but it's done within the transactions where the original data has changed. So it's like an aggregation of the permissions which are actually implicit in the original user data. And though, you know, there might be ones missing, but if there are ones missing, let me know, and I can extend that language a bit. So if you've got particular ways of assigning permissions to people.
There's two more questions in the room, and then there might be a question on the chat.
Yeah.
Hiya. Could you have like a like say an on-site kind of proxy fallback or multiple, so that your local device could connect to your on-site database if you couldn't connect through to the main one?
I hadn't thought of that. What you could, why would you want to? What would the use case be? I can't get what. So instead of having your main one, you'd have like a.
So you knew you were going to be offline for a long period of time, like you would have the world within that connection, and you did Apache, but you wanted to make sure your device data was backed up somewhere.
Oh.
If you couldn't connect through.
Oh, I see what you mean. So not on your device, but somewhere.
So yeah, so your device to your proxy to the main.
No, no reason why not, but we haven't thought of doing it. But it's a good idea. But yes.
Hey, first of all, awesome talk. I've often said authority models are one of the most important yet least talked about parts of data architecture. So thank you for the talk. I'm curious about the syncing aspect of this. So essentially role level security is quite great for wide-reaching permissions across your entire database. Things like social applications are particularly beneficial from that. If you block someone, you're blocked kind of across everything. Are you syncing the result of that to the device? As well as that authority model? Like, would you mind talking a bit more about the syncing?
So in terms of like being able to run permissions on the device, the user would get, there's a table in the main database called roles, and they would get all the roles that related to them. So they'd know what their own roles were. And they would also get a set of all the grants. So they would get all the rules that affect what you can do. So when they had those locally, they would be able to then look at a particular operation they wanted to do, like say a write, and check it against the cache they have.
And then if you add a write to the server, is that then synced to the device?
If it's online. But if it's offline, this is why you could potentially get this clash between permissions, and there isn't. You can have strategies for resolving it, but there's not like a clear answer. That it feels that. Those things are strategies rather than something where there's a clear-cut way. And in terms of tooling, we will expand the way the tooling works to kind of express those options, so that as a developer, you might go, this is a permission which we always want to guarantee. Like say someone's buying something, you want them to be able to buy with confidence and have that finality on the local device. But if it's something where you want to essentially regain more control, you could say, no, we're going to be able to shut you off if we want.
From a security perspective, are you syncing more data to the device and then applying the authority model on top of that?
No. So in terms of only the stuff that is defined as readable by that person hits their device. No.
If you can add on something on a Tuesday, but not a Wednesday, you would take that on global Wednesday.
So if you did a write on the Tuesday, and your permission was revoked on the Tuesday, and you sunk on the Wednesday, it depends on that behavior, whether or not, and that would be probably a developer or someone would have to choose, we're going to allow these people to make these writes late, or we're going to block them and stop them doing it. Potentially, you could also go, we'll let you do it for a day, say. If you're offline for the first day, your writes are good. After that, you might find they fail. So there are different strategies that developers will have to actively author about the behaviors of permissions, which will be part of working with kind of local first sync permissions.
Thank you.
Pleasure.
I think there might be
Yeah, I think we're done. Sorry, I've gone over time.
No, don't worry. I think there might be one question in the chat, which if you open Zoom, click on that chat there. Here's a question.
I don't know is the answer. I was actually thinking about that on the way in. It's
So Paul can just read out the question. So
sorry, the question is, in a pure peer-to-peer deployment, no backend, would DDLX make sense? I'm not sure it would. It's lots of the stuff is quite specific to a kind of central database with remote clients, but some of the patterns would probably work, but I haven't thought it through. But it's interesting to do so. I will think more about it. Thank you. Okay, I think that's it.
Yeah.
Thank you.